Well, hi, good morning. Thanks so much for joining me in my shop here. It's May 18th, and I'm ready for another brain-busting session with this radio. It certainly is busting my brain. So it's been quite a few days now where I've been working on this radio, trying to solve this motorboating humming problem related to the position of the volume control. Turn the volume control down and away she goes. Along the way, I've been searching very hard for some kind of wiring or component error. I haven't really found any, but I have found two components that needed to be changed. Capacitor and a resistor. I made those changes. Capacitor did nothing, but changing this resistor had a subtle effect on the nature of the oscillation or motorboating. So we're close. This is definitely in the circuit path of the oscillation. Actually, I started thinking there might be 2 or 3 different oscillations in here all on top of each other. Maybe that's why I'm just going around the bend. But mostly, I've been thinking about how to gather brand new, fresh information, and I thought of a good way. Maybe that'll lead to a breakthrough. A good way would be to pull out a couple tubes here and there and operate the set and see if the oscillation continues with the tubes in or out. I don't exactly know now what that's going to prove. I'm going to make the observations and then I'll think about the result of it. So obviously if we pull out audio tubes we're not going to hear it because it's not going to come out the speaker, so we're a little limited in doing this. The first tube I want to pull out is the first tube in the radio, which is this one, which I just want to double check. I don't want to make any mistakes here. Yeah, that's the very first tube that the signal encounters in the radio. We're going to pull this out, operate the radio, and then think about what the result is, what the result means. Okay, here we go. One tube down. Now I have to make a special effort to remember to stick it back in before I carry on afterwards. Radio should be very quiet. It shouldn't have any effect from antenna input. Well, okay, that's good. Now the pulse of the motorboating is the pulse rate's gone way down since I changed that resistor. I pulled the first tube out, didn't seem to make any difference, so I chopped off a big chunk of the schematic, so to speak. Can't be involved in this. Unfortunately, it really, well, I just pulled out the next tube, which is kind of crazy. It's the one that I think is doing the oscillating. This guy. But you know, the components down around that tube, that's an audio tube. Now let's keep pulling these tubes out. I think I could do this with the set operating. Can I? Can I do that? Let's not. I'm sure I could, but I'm not going to. The thing about pulling a tube out is you're going to probably put your hand on the chassis like I just did, and your hand on the chassis, you're halfway to getting a shock. Wow, this radio really hangs on to its tubes. Okay, that guy's out. 2 tubes down. What do you do now? Now, is there any reason I should really be concerned about operating a radio with these tubes missing? Wow. Wow, okay, this is quite, this is a good idea. The next tube to pull out would be an IF tube. You know, the volume control is kind of connected with the audio part of the radio, so I shouldn't be too surprised I'm able to pull all these tubes out and still get the effect. It's gotten a little warm. And they have a left glove. We have another beautiful day, weather-wise, coming. Tomorrow, oh my gosh, tomorrow they're thinking the temperature may get up to 30, which is very hot for this area. 6SK7. Okay, we are thoroughly denuded of tubes. Now basically the radio part of this radio is gone. I think that's what we could say here. Maybe those tubes weren't needed all along. Just run it without them. Okay. Tell you. I may as well do it. I'll pull out the detector tube and the first audio amp. That leaves only the output tube in there. Not very warm. Yeah, I think I'm just going to run it on the lower supply voltage now, because I'm not loading the power supply very much, so probably the power supply's gone up in voltage. Well, of course, the volume control is no longer connected to the output of the radio. That pretty much finished it off. So the interesting thing here is we got all the tubes out. It's really only when we pulled this one out that things went totally quiet. So even this tube, the detector tube out, really, wait a minute, no, the detector tube is the one we're talking about. That's the output tube, get it right. Pull out the detector tube, that's when things stop. Not terribly helpful, because I know the problem's all in this area here. Well, I gotta come up with another idea now. Okay, I found a couple things in my box of long shots here. One is this resistor right here. I put this in a few years ago. I'm pretty sure it looks like the kind of thing I would do. This is supposed to be a 270 ohm cathode resistor on the output tube. This one measures just under 500 ohms. Can that cause this problem? I just can't see how. But that's not the end of this story. This has a bypass capacitor. There it is there. There he is there. Now, because I'm, somewhat of a lazy person, I decided to use this terminal as the ground for this capacitor. That may not have been the wisest move. Maybe I should really put this right to a terminal like this one that goes right onto the chassis, like really ground it right to the chassis, rather than ground it into some wires. Is there any chance that either of these would stop the motorboating? Not that I can see, but I'm going to change those to what they really should be. What and how they should be. Okay, I've made that change. This is the resistor I took out. $484. Should have been 270. What was I thinking with this? Oh my gosh. Me in my younger days. Hey, it's only 3 years ago. Not that much younger. Okay, so we're going to try the radio now. I'm going to see that it didn't make any difference. And then I think I'm going to call it quits for the day, because the weather is just too nice to be down in the shop, and I got bad weather coming in the next couple of days, so I'll be able to get better shop time. Okay, let's give it a go. Yeah, I really have to think, okay, I give this a 10% chance of having ended the misery in this radio. I'm not even putting money down, I'm just giving a percentage. Okay. No way. Did I put all the tubes back in? Is this a radio without tubes? It's a radio without sound is what it is. Oh! Hold it. Speaker not connected. You gotta be kidding me. Hold on, I'm still on the dim bulbs here. Really? No way. Listen, it's laughing at me. This sounds like a great 1950s car or something here. Warming up. Okay. Gun it. And we're shooting down the highway now. Off into the distance. Okay. I thought for a minute there I'd actually succeeded. Piece of it now. Oh, as I promised, that's going to be it for today. Hey, how many radios do that? That's fantastic. You need a real special radio to have it do this. Okay, so I'm not going to post a video. I'm going to come at this again tomorrow and see what we can do. Did I say I was going to stop? No, I'm not going to stop. I found something else quite interesting. So here's an original capacitor sitting here. You can read it. It says 4 microfarads. You can read it now because I rotated this. This was rotated. You couldn't read the value on it. 4 microfarads. Here's a diagram that shows the parts layout in the radio. Oriented the same as the radio. It's like this. You know, that part is right there. The number on the part on the sheet is 28. There's no question, that's a 28 there. When I look at the parts list, I won't put it on the screen, I'll just look over here and tell you that capacitor 28, right, C28.1 microfarad tubular. 0.1, but it's got a 4 electrolytic here. Now, a vague memory's coming back about a problem with this and another capacitor in this area. So when I look at the sheet, there is another large capacitor here, C36. When I look at C36 on here, it's a 4 microfarad electrolytic. So this is C36, but it's sitting in the C28 position. I have a vague memory of coming across all this earlier. But did I ever rotate this and find out this was the 4? I don't know. And what happened to C36, this big one? There's a big one here now. Where did it go? So I'm going to pursue those 2 questions. There's probably nothing to it. I probably just relocated C36. It's a smaller capacitor stuck somewhere else in here now. That's probably what happened. So I'm going to hunt it down. C36. Wow. C36. 4 microfarad. Where are you? Okay, didn't take long to find out what I did with the 4. It's now here. It's a little hard to see in the camera. There's a dark electrolytic, black electrolytic capacitor right there. Probably wired in properly, but I did go from below this panel to above. Now chances are this is here because this was a great place to put it when they designed this radio. That's why it's here. Or is it here because for some reason you want this on the other side of this plate? I have a hard time understanding, believing that. But in any case, there's the 4. Now the other one I need to find was the 28, C28. Okay, where's C28? C28. It's a large, well, it would have been a very large 0.1 tubular. C28. C40. 28. There it is. Oh, look, it's involved in this. Huh. Where is this? I have to find this guy. A 0.1 coming right off the switch. S2A. S2A is in the second position on the back. If that makes any sense. Find this capacitor. It has to be kind of obvious. It should be fairly obvious. So let me get a 0.1 in my hand here so we know what they look like. How's this a 0.1? 104. Pretty sure that's a 0.1. That's what it looks like. There's one here. One here. What's it doing up there? Is that the same one? Just relocated again. So one side goes to ground, the other side goes to a terminal on the, I think that's a 6. I'm not sure what that is, what tube that is. Okay, does that go to ground? Does that 0.1? It does. The other side is connected right into the switch. So it would have to be a wire running all the way to the switch. I can't imagine that. Well, there is an orange wire here. It's the orange wire. The orange wire that comes down and meets a terminal down here. I don't think that's it. I think that's another 0.1. Did I miss the 0.1? Wait a minute, I see a 0.1. Yeah, you can see it on the camera. I can't see it from where I'm standing because my eyes are up here. By the way, this is what I'm seeing all the time, in case you're wondering. Yeah, that's what it looks like, all right. I'm sure you weren't wondering. So here's a 0.1. This is probably the guy. This is a ground terminal. This other terminal follows one of the exciting white wires onto here. So one side is going straight to the switch. Okay, I'm going to investigate this a little further on my own because it's going to get a little too complicated to talk on the video. Okay, so I'm continuing with the theme that I messed up the last time I worked on this radio, and I'm just going over the things that I did. And I'm recalling a few things. I'm recalling confusion around these two white wires, which one should go where. Should they be this way or should they be that way? So by studying the schematic very carefully, looking at the switch very carefully, I determined those wires are in the right position. Okay, so that's over. Next, I stuck a capacitor in here. We'll take a look at the size of the capacitor. Really, I can end up being very critical of myself here. Here's the capacitor. 50J, it does say. It's not 150J. It's 50. Is that even a 30? I think it's a 50. because you can see the 3 down below how they did it. So that's a 50. But on the schematic, here, the schematic's right here. On the schematic, it's C28, 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 .1 micro. Whoa! Something really went wrong there. I did something totally wrong. Yeah, I picked the wrong capacitor here. Okay, hold on, everybody, slow down. We're up here, aren't we? This is on the a capacitor related to the input side. Yeah, so it's a capacitor off of this terminal where it says R8. C30 goes up to the negative bus. That's the one. C30. Okay. Let's C30. C30 is a... Oh, it's a 50. Okay. Oh, okay. Everything's fine. My mistake previously. So that's good. So that's 50. So there we are. Not a mistake. Doggone it. I need some mistakes. I need some mistakes to fix here. Yeah, okay, well, that didn't pan out. Now I did, in this radio, I chose to use, you know, I think I was really low on capacitors when I did this radio. I used a bunch of these, I think these are tantalum capacitors. My assumption is a capacitor is a capacitor is a capacitor, and radio like this, what does it matter? I still think that's the case. Why is there a great big wire sticking out there? Jim, you didn't cut back the lead. Okay, that's not good. That's not good. I left this great big excess lead hanging out here. Whew. Shame. Almost grounded. And now a quick lesson on pliers. One of these pliers is not like the other. One of them will bite your thumb badly. This guy. See the space in here? The gap right in this part? When you're operating, quite often you get your hand up here. This plier, they actually have a gripping surface in here. This is actually meant to be part of the pliering. You can plier something with that. But what you end up pliering is your finger. This is a bad one. And you know, if you do this work, you know when it happens, right? When you got this on something round and it snaps off. And that's when it grabs your thumb. So danger, not so dangerous here, but your hand is generally back further on this one. And not inclined to get your thumb up here on this plier. I don't use either of these normally. My regular tools are sitting somewhere else in the house at the moment. There we are. Don't let your pliers bite your hand. Now. I gotta come up with a whole new concept here. I need a new concept. Okay, I got another fish on the line here. Another area where I may have made a mistake. And what I'm doing is I'm following the wires coming off the back tab of the volume control here. So there's a resistor you can see, but there's also a red wire. You have a hard time seeing it in the camera. That red wire is this red wire here. Whoops. There we are. This red wire here. As I'm showing this to you, what I'm really doing is I'm reviewing my theory. Red wire reaches a terminal. Come down following the blue line here. Comes out to this section. This is S2D. That is this section with the R20 33K resistor on it. In fact, that's what you're hooking up to. You're coming into the 33K and a C40, which are both here. C40 is back there. Oh, this is where it gets interesting now. If you follow the other line of this resistor around the switch, you see it connects. You have to look really careful what they've done here. It connects to two switch posts, and the capacitor carries on to another connection. Where is that capacitor? C41. C41 is a 0.01 tubular capacitor. That's a pretty easily recognized capacitor. It should be right there. I don't see any capacitor. Let's take a closer look at the situation. Once again, I think I found something. Maybe under close observation it won't be the case. So here we have the red wire. It comes in, it meets that blob of solder there. It looks terrible. Let me wiggle that capacitor. Yeah, it really looks like there's a cold solder joint, but I think it's probably okay. One way the capacitor, the other way to this resistor. Here it is. And then beyond the resistor, it should catch two terminals. 1, 2, and then there should be a capacitor carrying on. 0.01 capacitor. Where are you, man? It's not at this end. Was it once on that terminal? Is something I cut away and meant to change and never did? Is there some other place I could have put it? I can't imagine there's any other place. It's supposed to carry on and make a connection way back around here somewhere. Oh my gosh. Yeah, a little tough. There's no more terminals to connect it to. What's it show? What's it show? It's here. R20 comes around. They show this weird arrangement. This is a weird thing. Why are they showing these three connections separate? Why aren't they all bundled together in one dot? Show them all separate. And then there's C41, and it goes over to, okay, so the ring contact. So the way to recognize this terminal here, this one, I have a bit of a dashed line there, but I think it's just weak. I don't think they meant that to be dashed. So they're not dashed on this one. I don't think it means anything. So that contact goes under the sliding wheel, probably contacts a ring in the middle, whereas all these other contacts are on top of the rotating contactor wheel band. So I got to find the one that goes underneath. And it should really just be the next one beyond here. Okay, next one beyond here. Okay, so this is here, right here. Next one beyond. I don't see any terminals. It really is, okay. So there has to be some kind of a, what is happening here? Okay, so that's the last one. Then there should be a capacitor to the next one. But there is no next one. There just is none. This is really a problem here. I have to, I'm sure I've taken this switch and manipulated it, like slid it back and rotated it a bit to get at things. I may have to do that again. That causes a huge disruption. All these wires. Oh boy, I don't really want to do that. So, where's that capacitor going? It's going to the slider, right? But that's the same as this blue wire. That's the same as this connection. That's the same as the feedback line from the speaker. That the blue wire is the feedback line. So all we got to do is make a capacitor connection from anywhere on this feedback line to anywhere on this wire past R20. Okay, so is it just, so you know what? So wait a minute, so there is a capacitor. No. No. That's the other one. That's C40. That green one. C40. What's that one? Back there. Well, this diagram shows two capacitors on the switch, and there's two. That's one of them. Could that be electrically? Look at the green wire there. Let's see, it's connected. And that is a it's supposed to be tubular, but it's not. I put a I'm sure I put a 0.01 there. 0.01? 0.01? 41. 41. Where'd you go here? 41. 0.01. 0.01. 0.01. Oops. Did you fall off your chair there? 0.01. So if that's not it, what is that? I mean, that has to be it, or it's it in the wrong place. You know, I could very well have gone through the same kind of thought process. Can't stick it in down here, got to stick it in back there. I must have taken this switch right out. And that's what caused all these problems. I took this switch out to get at these capacitors in the back, and she never worked again. Now, almost certainly these capacitors went in where there were other capacitors. You know, place for place. So my ohm meter might be helpful in figuring out if those terminals on that capacitor is the same as up front. Let's try that. Would have been quite easy for me to make a mistake at this point. Actually, I find it pretty easy all the time. So we'll get on one terminal of that capacitor, and then we'll look for it down here. That doesn't seem to be it. Okay, now we'll go to the other terminal, which I don't know if I can get to it. Not with this. It's way back there. No. No can get there. How am I going to get there? Clip lead one terminal here, so I don't have to hold on to it. I'll clip it here. Okay. The other lead from the meter I would clip on my screwdriver. I will deputize my screwdriver. Now an ohm meter lead. Let's test it. Very good. And I'm going in there with this big bare metal thing. Okay, I'm on. Hey, it didn't show a ground, did it? Let me try that again. So this I should be finding. Well, there's nothing hooked up to this. How can it possibly? How can this possibly? Because there were some hidden wires. No. What? I mean, it would have to be connected to this. Just considering that, you know what? It's not even. It's on the. Wow, this switch is a monster. You see the wafer? See the terminals here? These terminals are actually for the back side. These terminals are actually for this side of the switch. And when you look at these diagrams, it is just monstrously confusing. And I am monstrously confused again. So no ground on no short on either side. And visually no, and logically no way to make a connection from here. So now the question is, if that capacitor is not hooked up here, what is it hooked up to? What is it doing back there? That's going to be a little. I'm just going to stop and examine it on my own. Didn't take very long at all. What I can see pretty clearly is this capacitor hooked up to this green wire. This green wire has a jumper wire to a terminal back here, and on that terminal is this capacitor. So these capacitors are essentially in series. What is happening? Okay, I believe I proved this one to be correct. So we can follow in from here. This is a certain area. Follow in a resistor, capacitor, and what comes next? Oh, I got the schematic right here. Let's look. Let's look. And what did I say again? Resistor, capacitor. I can look at the radius stuff. Okay, starting with the volume control here. And what we're following along is on the input side. No, we're not. We're on the we're on the side of the capacitor here. That's the input side. Input side. Okay. Good. Input side. Input side. How many times are you going to say that? I'm going to say it until I have something else to say. So if we come from the volume control, we encounter a resistor, R10. R10 is 220K. Okay, and there's 220K right there. Right there. The capacitor is going to ground, which it is. The resistor carries on. It encounters first this capacitor, C31. Carries on and encounters. There's a resistor. Ugly looking soldering. Finds that guy. 223. 223. 31. 31. 0.02. 22. So 0.022. 223. 223. Is that absolutely correct? 223.02. I have to check by looking. 223 is correct. In fact, if you look in my drawer, you can see I still have a whole bunch of those guys. Look at them all in there. I got those guys, I got these guys, I got all kinds of guys in here now. Lots of different capacitors. But that's not the problem. Okay, so this is fine. We've made it all the way to here. Now we go to another terminal. And on the green wire. The green wire brings us right into the switch, onto a place where a number of switch terminals are joined. Onto a place where a number of switch terminals are joined. So we're going to follow from I've lost it. Here we are. R10. Get over to C31. It connects to a number of terminals that are connected together. There they are in the switch. You see all these are all connected together. But at the same point, it finds another capacitor. At the same point, it finds another capacitor. So that's the t'other capacitor. That's what that is. The one I'm worried about is the other capacitor. the other capacitor is supposed to go to the center ring. Oh, it's all so far out of sight. Oh, it's all way back in there. Yikes. So it's just way back in there. The radio does work other than the humming and the motorboating, so I can't think that this is terribly wrong. How could this be wrong? I don't think it can be wrong. So we know that C34 is spoken for. You know what? I think there's a capacitor missing. Okay, and again, what makes you think that? Because if you take R20, which is 33K. R20, hey, they crossed one out here. 33K. 33K. 30, come on, light. 33K, there it is, right there. And you follow it, coming out, it ties to 2 terminals and then a capacitor. Way over around. Actually, it's a capacitor from here, basically get onto the feedback wire. Anywhere on the feedback wire. But it has to come. Why did they show it like that? 3 dots. Okay, so that's here. I got the clip lead. Now, is there absolutely nothing on those terminals from this resistor? There's something tricky going on that I cannot see. There's nothing there. Now, did I cut something off of here? Huh. Hard to say. Or it could come off this terminal. This one looks a little roughed up. So, okay, if I'm going to run a capacitor from there to the feedback wire, this is easy as pie. Because the feedback wire is this blue one right here. This blue one is the feedback wire. So you run a capacitor from that terminal to here. That's it. I don't know. How could that not be it? I should put one in and see what happens. I mean, what can really go wrong here? It's a capacitor. It can't let any DC through, so I mean, you can't really make a terrible situation out of this. Let's put this in. We'll put this in. See what happens. Put this in according to my current theory. I left a part out. That's my theory. I went whole hog. I put a 1,000-volt capacitor in there. Okay. Are we ready? Volume up a bit. Switch the radio on. Apply the power. What's going to happen now? Somehow, I just don't think I've done the right thing here, but let's see. Okay, full power. Okay, here we go. First, wow, I don't know about this. Antenna? could argue that it has to be something connected to the volume control, because the volume control is integrally involved in the way this operates. I don't think that capacitor did me any good there, but I'm going to leave it for now. And I'm disappointed. I'm going to stop for a bit and go outside and see what's happening.